computing expected value. Example. Okay, so the function we're going to use here is this. So this is our probability distribution, is 1/32 times 3x times 4 minus x. And this is defined on, so we're restricting this to 0 to 4. So, and outside of that, it's 0. Okay, so that's our probability distribution. And compute the expected value. Remember, that is sum up all possible values of your observation times the chance of seeing it. Okay, our function is this, and we know that it's going to cut off at 0 to 4. So it'll be 0 to 4, and then x times 32 times 3x times 4 minus x dx. Okay, and so now all that's left is just compute this. Before I do that, just again, so the reason we're cut, this is 0 otherwise, so if we, let me just do that. So from 4 to infinity is going to be integral of 0, and then plus minus infinity up to 0 is also going to be 0. So these both drop. So the only one we need to really focus on is this one, which we'll now do. This is straightforward. It's just a polynomial. So I'm going to pull the 1/32 out. The other numbers here are actually going to be helpful in the computation. The 1/32 is to make sure that this actually is area 1. Okay, so what we need to integrate is 12x squared minus 3x cubed. So I found that just by, so this is 3x squared, and then you distribute it. So 12x minus 3x cubed. The antiderivative for this is going to be 4x cubed minus 3/4 x to the 4th, and we need to evaluate that from 0 to 4. And we have this 1/32 there. Okay, so plug this in. So we have 4 times 4 cubed minus 3 times 4. Now I'm going to write this 4th power as a single times the cube. You'll see why in a second. It makes computing it easier. So we have that, and then minus, and this is 1/32, and then we have minus 1/32, 4 times 0 cubed minus 3/4 0 to the 4 cubed. This is 0. This is 0. So this term over here is all 0. This one, though, we have this common factor, which is 64. 4 to the 3rd is 64. But these ones cancel. So we have 4 times 64 minus 3 times 64. And then 1/32 in front. So this is 64 times 4 minus 3. So that's 1/32. So it's 1/32 times 64, which cancels to just give 2. So the expected value of this function here, that is our expected value, or also as mu, is 2.